So here's another example that we can look at using chain rule, and we'll try and set it up exactly how the pattern that I want you to try and use in class. And so what we've got is x of t equals cosine of t squared plus 1, and we're talking about an object that moves along the x-axis. So, and this is position. Remember, position, derivative is acceleration, or is velocity, and the derivative again is acceleration. So if we want to find the velocity, we need the first derivative of this. And so we need to find dx dt. And the way that we're going to do that is we're going to find dx du, and we're going to multiply it with du dt. And again, what we're wanting to happen is we're wanting these du's to cancel out. And notice when they cancel out, I have exactly what I need. So let's let u equal the inside part. We're going to let u equal this inside part right here. So we're going to say, hey, u equals t squared plus 1. So du dt is equal to 2t. We're going to say that x of u is equal to the cosine now, not of t squared plus 1, but of u, because look, we've picked what u is going to be. And so dx du is going to be what? Well, what's the derivative of the cosine? Negative sine u. And now we put those two things together, and we're going to end up with dx dt and that's going to equal 2t times negative sine of u, which is, whoops, not 2. Let's see, let's get rid of that guy, which is t squared plus 1. So how would we look at this as our final answer? We would simply say, for our final answer, that negative 2t sine of t squared plus 1 would be the velocity of the particle. Okay. Well, what about taking the derivative, differentiate, find derivative of x squared plus x. Wow, what's going on here? Well, x squared plus x is inside sine. So again, we're going to do it this way. We're going to find dx dy is going to be equal to dx du times, whoops, not dy, du dy. Okay, so we need to figure out what u is. U is going to be the insidemost part. Here's u right here. U is going to be this inside guy. So u equals x squared plus x. Du dx is equal to 2x plus 1. Okay, that gives us then for y going to be equal to sine of not x squared plus x anymore, but u. We're replacing x squared plus x with u. Okay, that's why we picked it. So now we're going to go with dy du, and the derivative of the sine is the cosine. Okay, and so when I multiply the things together, dy dx, I wrote that completely upside down. And let's trade these two guys. So dy dx is equal to dy du times du dx. So dy du is cosine u. what is u? U in this case is x squared plus x times du dx. What is du dx? Well, du dx is let me see, having a hard time getting my stuff straight here. Du dx is going to be 2 times x plus 1. Okay, so what is this going to look like when you're all done? Well, it could look like where you're at right now. There's really no need to FOIL all of that out unless you wanted to move the 2x plus 1 into the front. It's just going to be kind of a little bit of a longer problem. But this is a good answer for using your chain rule. Okay, so look for that inside thing. That's your u. The outside thing is the function for y. And we're going to take derivatives of both of those. Again, it's going to take a little practice, and think about that peanutty M&M. Start with the peanut, go to the chocolate, go to the candy shell.